Oh, hi. Friendly neighborhood geologist here. Dr. Burston, if you didn't know, and I would love to introduce to you Dr. Frost, my friend and colleague. Hi, Dr. Davy. I see you're interacting with our colleague, Dr. Frost.
Dr. Frost allows us to make blocks of carbon dioxide. So when we get carbon dioxide as a solid, you might notice dry ice, we have two different options. We can order 50 pounds from Vancouver. In the time it takes to get from Vancouver to Squamish, we'll lose about 15 pounds. And then we'll lose the next 35 pounds over the course of about a week, even in the deep freezer. So what Dr. Frost lets us do is make 1 pound blocks at a time whenever we need it. So that's what we're going to do today.
She's a pretty fast worker, if I recall correctly.
It only takes us 3 minutes to make a pound of dry ice, which is pretty awesome. Right now we're going to show you the empty setup, and then we're going to hook it up and show you how we actually make the blocks of dry ice. So I'm going to lift off the lid and open it up, and you'll see on the inside that we have these sort of like insulating panels inside of the wood box itself. It's really easy to reassemble, hopefully.
It is.
We put the 2 slots back in. You'll notice everything's locked in place. The lid goes on and snaps on in 4 places, giving us both a good enough seal to pressurize in the box in order to make the block of CO2, but not so tight that we can't leak out the sides, which then accounts for the safety of making a block of CO2.
Speaking of safety, one should always wear appropriate eyewear while operating in the lab. Thanks for the demonstration, Dr. Frost. All right, folks, Dr. Davy is going to turn the pump, and we are going to get loud in here.
That is correct. So you'll notice that the CO2 maker is now hooked up to this gas cylinder here. This gas cylinder is special because it has a siphon that runs from the dial to the bottom of the cylinder where liquid collects. And so we get these specialized cylinders. This is 55 pounds of CO2 with the siphon in the bottom. We're going to turn this on, and it is going to get really noisy. It takes about 3 minutes to make a block of dry ice. You will start to see some smoke coming out the sides here. That is the reduced pressure from the CO2. And ideally this is going to work. I'm going to keep an eye on the pressure from the cylinder here to keep it at about 5 to 10 psi as we go to fill it. We're getting close to the end here. You can tell because the sound has gone down because it's occupied more space. And at this point what we're waiting for is for this to spool. See the smoke coming out the top? She's done.
What you got inside, Dr. Frost?
All right, let's take a look. Eyewear off. Lid comes off. Sides come down. And up the side. A fresh, complete block of solid carbon dioxide.
Yeah. Thanks, Dr. Frost. Don't touch it, Dr. Davy.
Woo-wee! Yeah, I know, it sort of reeks. Okay, so.
Hello, friends.
Hello. So now what we're going to do is we're going to
Lord.
The ammonia?
The ammonia.
So we're going to demonstrate ocean acidification using the solid CO2 that we just made and water. But before we do that, we wanted to show you how we're going to see what's happening using pH indicator. So we have 2 beakers here one with acid, which is vinegar, one with base, which is ammonia, which is what we're huffing back here. And so we first wanted to see what color this indicator would be in the two different solutions.
So that you could see it.
So that you can see it. So this is universal indicator. It's the one that's the cheapest and easiest to get our hands on.
Wow.
You will note that in the acid, which is the vinegar, it has this like really lovely pink color to it. And in base, which is the ammonia,
Lord.
which is hitting Natalie a little harder than it hits me because I've spent years burning nose hairs off. It is this lovely green. This will now go elsewhere, so we don't have to smell it anymore. So
to reiterate, the acid color was pink and the horrific bat pea color was blue.
So, if we're thinking about ocean acidification,
what's causing ocean acidification? Here we have this beaker filled with just regular tap water, and the pH indicator will show that coming up as...
we're going to add a lot just because there's a lot of water.
So what are our causes of ocean acidification? Well, basically the causes, plural, are humans, and what humans are doing. And that is burning fossil fuels, right? So that releases carbon dioxide into the atmosphere. And Dr. Frost just made us a big block of solid carbon dioxide, so we can simulate getting carbon dioxide absorbed into the ocean by adding some carbon dioxide to our ocean water beaker. And what's really important is for us to see how the influx of carbon dioxide into this water changes the pH.
So what you're seeing is quite a lot of fumes on the top. Those fumes are CO2 gas. And so you'll notice that Natalie and I are standing pretty far back from this so we don't fume ourselves out with CO2, make ourselves feel gross. You'll also notice that it sort of looks like fog in old movies, which you're all too young to know, but you should watch anyway. And this is how they actually used to make fog on creepy old movies, is they would add carbon dioxide, dry ice, to water in order to make that like creepy lagoon sort of fume thing. So we're going to hit this hard with lots of CO2. Excellent. You should see quite a lot of bubbling on one of these blocks. This is good. So we're now going to start to get a lot of CO2 put into the water. You'll also notice it's super creepy lagoon.
Wow, that ammonia bat pea is really just amazing.
There we go.
Get that boiling away. So the bubbling is actually the carbon dioxide going from solid to gas, which you should all remember from introductory chemistry as states of matter undergoing sublimation.
Oh, this is awesome.
I love playing with. Aren't you guys sad that you're online right now?
Take it over there. And ideally, you're starting to see a little bit of a color change. It can be hard to pick up on cameras sometime, and so we will let this run a little bit. But if we bring in our indicator for comparison, if you think about it, it was sort of this lovely pink when it was acidic, and we're starting to see that transition into the pink from that sort of orangey red we started with.
Maybe I'll go zoom the camera in while it's boiling.
I will continue to poke it.
I mean, the color you can see pretty well, I would say.
Oh, excellent.
Yeah. No, I'm not going to zoom it at all. Forget that. So in this example, we're ideally going to infuse as much carbon dioxide as we can into this beaker of ocean water. It's not ocean water really because it's not saline, but we want to get it as close to the pH of the vinegar as possible. In your ocean acidification lab, you're just using regular white vinegar, most likely. Perhaps you're using lemon juice or another alternative, and an eggshell. So I saved some eggshells from eggs that I haven't actually used yet, but will. And in your lab, all you need to do is take half an eggshell and put it into a glass submerged in white vinegar, and then you can observe from there how ocean acidification impacts the shelly organisms that live in the ocean. And shelly organisms are not just mollusks and bivalves like you might imagine, but it also includes all the coral reefs. So the big issue with ocean acidification that gets publicized a lot is coral bleaching. And coral bleaching is a result of ocean acidification is because the coral organism has a calcium carbonate skeleton that is highly susceptible to the acidification of ocean waters. So what exactly is the acid we're making in this ocean water? Dr. Davy, the chemist?
The acid that we are making is carbonic acid. It's actually the same acid found in soda. So if you all did that experiment in grade 6 for your science fair where you put a tooth into cola and watch the tooth decompose, something that gets brought up a lot is like, oh, it's the sugar that's leading to the decomposition. But that's actually mostly incorrect. It's primarily the acidity from the carbonic acid, which comes from bubbling CO2 into water. It's starting to get real pink.
It's starting to get quite pink. It still could go pinker.
It still go pinker.
So another way we can get carbon dioxide into our water experiment is not just by sublimating dry ice into it, but also to directly bubble CO2 into the water, which is how carbonated beverages are made in the first place. And really is also how CO2 gets into ocean water from the atmosphere as well. Obviously you guys don't have CO2, but that's why you could just use vinegar and get a pH that is equivalent for this, for this experiment. All right, well let's take a look and see if we can get a reaction with these eggshells with these solutions that we have on hand already. The white vinegar, which we already started with, and let's get some carbonic acid out of this jug into this much smaller beaker. Freshly made. Thank you.
And then we're going to use 6 molar hydrochloric acid as well. So this is much more aggressive acid. So we've got the 3 types.
And I got some little eggshells that I washed, and let's drop them in, see what happens. I think we're gonna have to do some poking, Dr. Davy.
That's fine. Oh, well that eggshell's done. That eggshell's done. So the eggshell in the HCl, I'm just going to describe what it feels like because obviously y'all can see, but you can't, you know, touch it. It went soft immediately. The second I pushed it in, it feels really slimy. It almost feels like a marshmallow. You know when you're like melting marshmallows to make Rice Krispie treats? That's what it feels like. You can see all the bubbling. You can probably work backwards to figure out what those bubbles are, ideally. The one in the carbonic acid still feels hard, but not as hard as it used to. And in the vinegar here, same sort of thing. Hard, but not as hard as it used to.
So in these analog models, obviously you're going to be using the vinegar model because that's most accessible at home. You should be able to make out that you can see bubbles even forming right away that we put the eggshell in there. Oh, I need to cut away and immediately look over to the reaction that's happening with our hydrochloric acid eggshell.
So you can see like how much foam is on the top. The eggshell is practically no more. It's actually a little bit warm too, which
you should recognize what that means in terms of chemical reactions at this point.
Look at all the foam.
And even in our middle one, we can see reactions with that carbonic acid, which is the most similar to seawater. And if we had have just added some sodium and other ions into this solution, it would be more comparable in chemical composition. But the point here is the acidity that we're looking for. So in these analog models, we're representing, of course, the process that is happening when oceans are undergoing acidification. Oh my gosh, that's so weird. Imagine that happening to a poor coral. Yeah. But the strength of the acidity is actually an analog to speeding up time. In this experiment, we can't rush through time, but we can increase the strength of the acidity to replicate more time in contact with the acid. So if you leave your experiment for a few days, you'll be able to get, well, you probably won't get that foam. I've never seen that before in my life.
It's pretty cool.
But you'll be able to see some reactions happening and observe the changes in your shell over time. Holy fuck, that ammonia though.
Oh, ruthless, eh? I think I'm not right. I thought I gave myself a gentle nosebleed with it, but no, I thought it was just my nose running to get it out. In you go, babies. Let's get this to the side. Have you use this station? I'll continue to poke this shit. Woo! Ammonia. This is never gonna get old.
No, playing with dry ice is the greatest thing ever.
Maybe don't put your face closer when something burns. More dry ice. In case you're wondering how your tutors are doing with online learning. Whee!
Oh, that's very, very, very satisfying.
Yeah, it really is. Watch your face just in case it blows up. That's acidic.
That's acidic. Awesome.
For the blooper reel.
That is fucking crazy.
That is wild.
What a